is looking at right triangles. And really the only thing we'll ever do with right triangles is what's called the Pythagorean theorem. Most people know the Pythagorean theorem but don't know what it actually is. Most people know it's a squared plus b squared equals c squared. And what it lets you do is, assuming you have a right triangle, which means a triangle with a right angle, a 90-degree angle in it. We usually know something has a 90-degree angle because they'll have a little box in one of the corners, like this. Those boxes mean 90. What it says is that given two of the sides of the right triangle, you can find the third. So you have to be given two sides. You can find the third. You can find the third side. Okay. So there are three sides to a triangle. You need to have two. Well, we need to be able to differentiate the special sides. Well, there's only one real special side, and that is side C. It's got a fancy name. It's called the hypotenuse. And the reason why it's special and why it's called side C and why it's also the only side in the equation that's by itself is because it's always your longest side. It's always opposite of your 90-degree angle. That's what also makes it the longest side, is because it's got the biggest angle attached to it, the 90 degrees. The other two sides of your triangle, we'll call that your A and your B. They're both called legs. And the reason why we can call them both legs is it doesn't matter if we actually swap around the A and the B because they're on the same side of the equation. So if you accidentally get A and B mixed up, no big deal. They're on the same side of the equation. The one that really matters is the hypotenuse. Always has to be by itself like it is in the equation here. And it's always the biggest side, the special side that's opposite the 90-degree angle. And it's got that fancy name called a hypotenuse. So let's look at solving some triangles. Again, they have to be right triangles for us to use the Pythagorean theorem. So they say find the missing side of a right triangle that has a side of A equals 5 and a side of B equals 12. So if they tell us we have a right triangle, we're always going to be using our Pythagorean theorem, our a squared plus b squared equals c squared. So let's plug that in. They're telling us that a is equal to 5, which is squared, and b, which is 12, which is also squared. So let's look at what that means. So the 5 squared for A is 25. The B squared, which is 12 squared, we have to do the exponents first, continuing along, would be 144. So now I can combine my like terms, which is I can add the 25 and the 144, which will get me 169. So I'm almost done though. Be careful. That gives me c squared, not c. So the question is, how do I get just c and not c squared? Well, we keep seeing this throughout this section is what gets rid of a squared is a square root. So we can do something. We can take the square root of both sides of an equation, just like we've done with other things. So we'll take the square root of one side to get rid of the square root. But then we have to take the square root of the other side. So what that does is that will get rid of my squared with the square root. They'll cancel out. And what that will leave me with is c equaling whatever the square root of 169 is? Well, the square root of 169 is just 13. So my side C is 13, which does, let's see, make sense. Remember, side C should always be the longest side because it's opposite the biggest angle, the 90-degree angle. So if our other sides were 5 and 12, our side C has to be bigger. So the answer 13 makes complete sense. Let's look at our last problem. On our last problem, we have the A and the C instead, but again, we still have a right triangle, so that's our dead giveaway that we're still looking at our Pythagorean theorem, our A squared plus our B squared equals our C squared. Our A on this one is 6, so that's going to be 6 squared. We don't know B, we're going to have to find that. They did give us at least C. So C was 9, which is again squared. So order of operations is going to make us do our exponents first. So 6 squared is 36, and our 9 squared is 81. We're going to have to leave everything else because we don't know what B is yet. So then you'd solve this like a normal equation. You'd get the B by itself by subtracting 36 from both sides. And that gives us that B squared is equal to, let's see, this is going to be 45 when we subtract the 81 and the 36. Now the question is, that's our answer for B squared, not B. We need B. How do we get the B by itself? We're going to do what we did in the last one. We're going to get rid of the squared by taking the square root of both sides of the equation. By taking the square root of both sides of the equation, that will get rid of the squared and leave me with just a B equals the square root of 45. The problem is we can't leave that the way it is. We can break down the 45 into something that we can take the square root of. 45 can be rewritten as 9 times 5. The square root of 9 is 3. And the 5 we can't do anything with, so that will have to stay inside of the square root. So our final answer for this one is 3 square roots of 5.